So with that, Dan, thank you so much for being here, and I'm going to kick it over to you to get this thing started.
Thanks, Phil. Glad I could be here today. So we're going to start off talking about why fall weed management matters and why it's becoming a really important topic for us in Northern Illinois and Southern Wisconsin. Originally from Northern Illinois, so fairly familiar with the agricultural community in Northern Illinois, and now I work in Southern Wisconsin, primarily in Grant, Iowa, Greene, Lafayette, Crawford, Richland counties, so down here in the corner by Illinois and Iowa. So we see a lot of water hemp resistance moving into our region. And this has really accelerated over the last couple of years. This map here on the left of Wisconsin, every county that's either red, gray, or striped red and black has been identified as a county that has a population of water hemp, and then the red indicates herbicide resistance in those counties. So we're certainly seeing herbicide resistance spread in our state. In Illinois, we've seen that in the news as well. So quickly spreading. So how can we prevent some of these seeds from spreading? And why is this important? Well, water hemp and Palmer amaranth, so our amaranth species, hold on to their seeds until harvest. The seeds are very small. I'll show you what those look like in a few slides. This is some data from a few years ago. The United Soybean Board did a project which University of Illinois and University of Wisconsin participated in. And this is looking at how many seeds are actually produced on Palmer amaranth and water hemp. You can see Palmer amaranth ranged from 13,000 to 50,000 seeds per plant. Now the literature will tell us that Palmer amaranth can actually produce up to 600,000 seeds per plant. And then water hemp ranged from 20,000 to 60,000. And again, the literature tells us that in some years, water hemp may produce up to 250,000 seeds per plant. That's a lot of new seedlings the next year. What's also important to note is most of these seeds, about 99% of them, are being retained until harvest. So that means until we go out and we harvest those soybeans where these water hemp, Palmer amaranth plants have escaped, we make contact with that plant with the combine platform, and it will shatter those seeds. And then of course we bring them in through the combine when we're harvesting soybeans, and we spread those seeds fairly evenly. This is mainly a concern in soybeans. And corn, we don't see the same results, but definitely a concern. So fall weed seed management, this is another table here that indicates how many seeds were captured in this study per red root pigweed, common ragweed, common lamb's quarters, and a few other common weeds that we have in the upper Midwest. We look at red root pigweed, 150,000 seeds per plant, and about 85% of those are retained. We look at large crabgrass though, 84,000 seeds per plant, and only about 40% of those are retained. So again, a little bit broader study, a little bit broader scope. Not every weed seed that we harvest out in the fall, that we see out at the fall harvest timing, is still going to be on that plant, but many of our common weeds will be. Water hemp seed, very small and can hide in the combine, can hide on pieces of tillage equipment, on soil. Very easy for this weed seed to be transported. You can see it next to a penny here, very small, and then next to a tip of a pin, again, a very small seed. So where do we see this happening? Well, when we go out and do our field scouting, if we see a small patch of water hemp out in the soybean field in, say, mid-June through early July, and it looks like we maybe missed it with a sprayer, that's the time that we should be getting concerned about this problem. These are some great photos from Ohio State University and Dr. Mark Lux, a weed scientist at Ohio State, to illustrate this. Small patch we think we maybe just missed when we were spraying, maybe the sprayer malfunctioned. We're not sure what the concern is. However, this producer went ahead and let this go to seed, and then we have this water hemp spread in this nice linear pattern throughout the field. Well, in year 2, we should be very concerned about this now and be targeting this to control it somehow. However, year 3, then you can go out into the field and it's a solid stand of water hemp, because that is just continually to grow and continue to escape. So that's why it's really important on the first year that you see problems like this, try and prevent those weeds from going to seed. Now, we've done some work the last couple of years on looking at combine weed seed dispersal. And since we went through that data, we know that common lamb's quarter, Palmer amaranth, water hemp retain a lot of their seed until harvest. This is water hemp, or this is a common lamb's quarter here, and then we have a little bit more common lamb's quarter in that photo. This is combine head, the gathering chains, and the stripper plates. You can see all those black dots. That's common lamb's quarter seed. So that was the combine harvesting a field with a lot of common lamb's quarter. You can see how that seed's picked up by the combine, and you can imagine how that's easily spread throughout that field and throughout that farm. So we've been doing some work in some clinics on this the last couple of years, where we go around to farms throughout Wisconsin and we walk through how and why this is important. Dr. Rodrigo Worley leads a lesson on weed biology and ecology for about an hour, and then I lead a lesson on how to clean a combine, which we'll discuss in detail today. But basically, there's many areas on a combine that weed seeds can hide, and we have a few areas that we can target. Now, this is a photo of every combine that we've cleaned in the last few years. And every single one of these combines, no matter how clean they looked, including this one here that looked almost brand new, had weed seeds hiding them in them somewhere. So where do these combine weed seeds hide? Well, we have the feeder house here, feeder house assembly, and we have these areas on this red combine that had these metal plates that created a little bit of a void. This combine was up near Green Bay, Wisconsin, and had just been done harvesting wheat. And we were looking around in the combine, exploring it, looking for weed seeds, and we found actually an amaranthus species germinating in that combine. So right next to, in the corner of the feeder house, we had a pigweed species germinating in that combine, which was an interesting discovery. And this biomass was full of little black seeds, indicating that species was present throughout the combine. So where do we think combines hide weed seeds? Well, there's a really nice study out of Iowa State that was actually published in a handout from Purdue several years ago that explains where some of this biomass hides in a combine. And if we look at this graph provided by that publication, we can see the head has quite a bit of biomass on it, as we can expect. The feeder house, we have a decent amount of biomass that we can expect. The rock trap, very easy to clean out. We can just dump that material out in the field. The grain tank, by the time we get to the grain tank, we're really thinking that weed seeds are not hiding in the grain tank unless we have a large seed, like say giant ragweed. That's a weed seed that we often see move all the way through. Unloading auger and tailing elevators, fairly easy to clean out if we needed to. And then finally, the chopper and the cleaning shoe areas really aren't hiding that much biomass. We're not too concerned about weed seeds hiding those. So when we do a clinic, we're focusing on the feeder house, the head, and the rock trap primarily. So what do we need to think about if we're going to clean a combine? Well, we always recommend cleaning it out in the field if we can before moving on to the next field. It takes about 30 minutes to clean a combine for weed seeds. This isn't going to clean it for identity preserved grain because, of course, you'd have to clean the grain tanks and the augers and that type of thing, which we have a few tricks for. But we want to be mindful of safety when we're cleaning a combine. We want to read, follow, and understand all the safety instructions that come with the combine and the cleaning equipment that we're going to be using. We usually recommend using a leaf blower. Works very well to clean a combine fairly quickly in the field. In addition, they're fairly inexpensive. You can even get battery powered ones. So they're fairly easy to maintain. Always use proper personal protective equipment when we're operating this equipment. We've had great success cleaning a combine with one of those big gas or diesel powered generators with the air compressor and everything built in. A lot of airflow, great to clean a combine. We would not recommend a pressure washer. The pressure washer is great for cleaning the combine potentially at the end of the season, but we're trying to get all that loose and light biomass out of the combine, and the pressure washer tends to allow everything to stick to the combine. So where are we going to focus? If we have 30 minutes out in the field, where should we focus on? Well, this is an interesting graph again from Dr. Hannout at Iowa State University in the Department of Ag Engineering, looking at where this material is at and how long it would take to clean a combine. So fairly complex graph here, and the brown data lines includes the average pounds of broken corn and form material collected from 5 combines. The brown grayish color has the average pounds of foreign material collected from 5 combines after harvesting soybeans. So our corn and soybeans are represented. And then finally, the blue graph represents the amount of time. So what we're looking to maximize is the most amount out of the brown graphs and the least amount out of the blue graphs. So that's where some of our recommendations come from. When we're looking at a combine, we can maximize cleaning the platform, the feeder house, the rock trap, and parts of the rotor fairly economically for our amount of time that we have. And that's where we've been finding the weed seed. So we can expect to clean the combine and get rid of a lot of the weed seeds, not all, just because we're only taking 30 minutes to clean the combine, and fully clean a combine takes several days to do that job. So we'll maximize the amount of time by focusing on those 4 key areas. And we actually did a follow-up study to look at where those weed seeds are in the combine. So this is some work from Nick Arneson, outreach specialist for University of Wisconsin.
Said something about somewhere along the way.
Weed
Said
science
something about
program.
it's going to be recorded.
And Dr. Rodrigo Worley, who's the extension state specialist for weed science at the University of Wisconsin for row crops. And what we did in this study was we asked producers to send in samples from those target areas to see if we could grow out in the greenhouse any weed seeds from those samples. And the results were really interesting. So 31 producers participated, accounting for 31 combines in the study. 97% of the combine samples contained viable weed seed. So 97% of those had weed seed spreading throughout the combine. Most frequently, 68% of the samples had grass weed species, 55% had pigweed species, and 55% had common lamb's quarters. The combine head samples contained the most weed seed species, as those photos indicated earlier. 49% of the total weed seeds were from the combine head. The feeder house contained 49%. The rock trap contained 19%, and the rotor contained 2%. So a few of these photos from the study, Nick did a really great job putting together this outreach publication that's available online, and I'd be glad to provide that to Philip to send out to everyone if requested. This is the combine head samples and the feeder house samples. And obviously we had some corn and some soybeans germinate in these, but you can see some of the other weeds that we identified. We identified some grass, some velvet leaf, corn obviously, a pigweed emerging, a dandelion, and then a common lamb's quarter. So quite the variety out of all these samples. The numbers in black indicate the total number of weeds, and the numbers in red equals the number of weed species. So this one here, Nick had a fun time counting. 642 weeds emerged in that plot, and there was 3 species represented, mostly grass from the photos. This one had 66 weeds emerge and 3 species represented as well. So quite a bit of weed seed moving through these combines. To wrap up this study, again, looking at where these weed seed hide, the head 49%, we can fairly easily clean the head off with the leaf blower when we're removing the head for transport or out in the field. 19% were in the rock trap, very easy to clean out the rock trap. 29% were in the feeder house. Feeder house gets a little more complex if we're not removing the head to transport to the next field, of course. And then 2.4% are in the rotor. So the rotor is by far the trickiest portion to clean in the combine, we know, out in the field. So if you're going to focus on just maximizing your time, clean off the head, clean out the rock trap, clean out the feeder house if you're removing that head, you can expect to remove quite a few of those weed seeds. And another graph looking at the distribution of weed seed species in this survey. Tillage also moves weed seeds. We can see that soil cling to those implements in the fall, and that's going to move weed seeds between field to field, farm to farm, that type of thing. So clean off that equipment and be mindful of the weed seed spread. Now we often use weed seed or tillage to bury weed seeds to decompose. And I get some questions about this in Wisconsin, and I wanted to include this in this presentation as well. If we're using tillage for weed control, it's a hard reset. So our aggressive tillage is going to bury weed seeds 6 to 8 inches deep. However, if we do tillage the next year on that field, we'll bring those weed seeds right back up to the surface. So if we're using tillage for weed seed control, really want to limit that to maybe once every 6 years for a hard reset if that's absolutely necessary. So what's the cost of all this? So I said 30 minutes to clean a combine. Everybody's already thinking, gosh, I don't have 30 minutes to spend between my fields. I'm in a hurry. I'm not sure how big of a deal this is. Well, this is a big deal to your bottom line. Yield loss comes from competition for light, soil fertility resources, and water. And that photo on the right's a field of giant ragweed, Janesville, Wisconsin. You can see how small that ear of corn is. We can expect to grow 250 bushel of corn in Janesville, Wisconsin. We've been lucky if we got 20 bushels per acre there. So weed seeds are easy to spread on your farm, but hopefully thinking about this a little bit more holistically, spending those 30 minutes to clean the combine out may help you out.
Right now.
So what are some of the other methods we can use to control water hemp seed dispersal? Well, there's hand weeding, which is actually quite common in states like Arkansas to hand weed Palmer amaranth, unfortunately. There's the cost of failed herbicide attempts, the cost of tillage, yield loss in current and future years. Those photos showed everyone that. Increased cost to reduce the seed bank through aggressive tillage and aggressive residual herbicide use. And then export restrictions came onto the radar in 2018. China began getting interested in if we were shipping them weed seeds or not. So that's another avenue to think about. Photo on the right is actually a photo I took when I was down at the University of Illinois for a field day. They're looking at the Harrington Seed Destroyer for management. That's a tool that farmers in Australia developed and really like to control weed seeds. A piece of technology, it's a good tool to have in the weed control toolbox, but it is expensive and comes at a cost to, of course, operate. So final slide to wrap this up before we move into the cover crop portion. We want to avoid weed seed production to begin with. So use residual herbicides, use crop rotation, use a diverse set of weed control tools. Clean the equipment in the spring and the fall. Think about where those weed seeds may be hiding. We want to harvest fields with any resistance concerns last. So if we have a field of water hemp that has some soybeans hiding within those water hemp plants, we want to harvest that last if we absolutely have to. And we want to prevent field to field and within field movement of weed seeds. We want to manage that weed seed bank to try and draw that weed seed bank down and try and eliminate that weed seed bank by using those aggressive management tactics. And manage the field borders. A lot of times we see weeds like giant ragweed taking over fence rows or taking over the road ditches, and we want to try and prevent those from going to seed if we can. Final photo on this to show just how aggressive and fun water hemp is to manage. This is a hay rack near Lancaster, Wisconsin, and that's water hemp growing on that hay rack. This is whose farm we were visiting that day to see that there's water hemp growing on their hay rack.